Hello, I'm Kate Kelly, Regional President for Minnesota for PNC Bank. We are so happy to be here. What you do in business and in life is a vital part of the ultimate outcome. PNC applauds the 2020 Business Manufacturing Excellent honorees for their many contributions to our local community and to our world. You are leading and making this a better place for all of us. Thank you.
Good afternoon and welcome to TCB's Manufacturing Excellence Conversation Series. I'm Adam Platt, Executive Editor of Twin Cities Business. Thank you for joining us over your lunch hour. Today is the fourth event in the 5-week series that will highlight recent achievements, strategies, and responses to COVID-19 of all of our Manufacturing Excellence Award recipients. For those of you joining us today, feel free to use the comments section on the lower portion of your screen to ask our speaker questions during the webinar. We'll review those near the end of the discussion. This roughly 20-minute interview will be recorded so you can go back and watch anytime. Before I introduce you to our speaker, I'd like to briefly thank our sponsors, PNC Bank, ProStaff, and Ware Technology Services. We couldn't do this event without you. I'd also like to thank our industry partners, Minnesota Precision Manufacturing Association and Manufacturers Alliance, plus our video production partner, Studio 120. And now I'd like to introduce Rich Garrity, President of Eden Prairie-based Stratasys, which is being recognized for its quick and collaborative response to COVID-19. Rich has served as President of Stratasys Americas since 2016. He joined the company in 2010, serving as Vice President and General Manager for its Red Eye subsidiary, now known as Stratasys Direct. He then became Senior Vice President and General Manager of Vertical Solutions, overseeing the company's aerospace and defense, automotive, medical, and dental vertical business units, as well as the Stratasys consulting team. Welcome, Rich.
Thanks, Adam. Great to be here.
Thank you for joining us. So let's start out with a general question about Stratasys. We know you specialize in 3D printing. Can you give us a quick overview of the products you make and the work you do here in Minnesota, as well as globally?
Yeah, thanks. I think the story of Stratasys first really starts with how Stratasys was founded. And it's one of these kind of classic American entrepreneurial garage startup stories. Back in the late 80s, Scott Crump and his wife Lisa Crump literally invented this FDM technology that has now become the most widely used 3D printing technology globally. And this company grew up here in Eden Prairie, Minnesota, from the late 80s to where we are now. The company has expanded beyond that original technology into other 3D printing technologies. And we're using those technologies for everything from helping customers to improve their prototyping process, so to speed up product development, but now also out on the shop floor for manufacturing tools to help make the making of parts more efficient. And now even into final part production itself, where we're starting to see our technology being used for parts on airplanes and so forth. So a great journey that we've had as a company, started from the roots in the garage back in the late 80s. And we're very proud to be leading the 3D printing industry today and have a huge presence here in Minnesota, where we still manufacture a number of the key technologies and materials here right in Eden Prairie.
Okay, so Stratasys, like the rest of the world, was thrown a curve in March, and you folks were early to respond to COVID-19. How did you decide to jump into shield production, face shield production? And then what was involved in making it happen so quickly?
Yeah. So the first reaction we had was to make sure that the health and safety of our employees was paramount. And the second reaction we had was, how do we leverage this technology that we have for the greater good? And I think 3D printing in general really shined bright early on in the pandemic days, because 3D printing is great for making parts wherever you need them, whenever you need them. and it's a big complement to traditional manufacturing that has much longer cycles to get going. So when we looked at what we had, we knew we had the technology. We've got lots of great customer relationships that we could lean on, and we also have some really innovative cloud-based software that we use to basically put all this together. The first thing we did was we enlisted our customers. We had a coalition of over 100 customers that came together here in the US. We tapped into their capacity of our Stratasys 3D printers. We tapped into our own capacity with our 3D printers. We connected it all with this cloud-based software so you could see what the availability was across this network. And we could literally share the files and digitally and share the jobs. And we had us printing shields, our customers printing shields, and we were up and running in a matter of days. And we ended up printing about 125,000 shields via 3D printing right in the first days and weeks of the pandemic.
And in my notes, it says you guys have printed about 250,000 total. Is that still accurate?
Yeah, so the first 125,000 we 3D printed, and then the next 125,000 we actually injection molded, which is also, I think, a great parallel to how we typically see 3D printing today, where you need short run production and you need it quick. 3D printing is the ultimate answer. But as you have a little more time, and we had a little more time as the weeks went on, traditional manufacturing typically plays there, and that's where we moved it over time.
Has demand tapered off, and do you expect to continue making shields indefinitely?
So the demand, I would say, has moved more and more so to traditional manufacturing. So as the supply chains of the world have caught up, I think given the time over the last several months, more and more of those face shields will be done via traditional injection. That said, we have shifted some of our focus to other types of programs and applications, such as helping where we can with ventilators. For example, we ran a pretty neat contest, design contest actually, globally here over the last couple of months, where we took submissions from around the world to help create a rapidly deployable ventilator for emerging parts of the world that couldn't necessarily wait or afford the more expensive ventilators. And we had over 200 design submissions for that contest, and we recently just picked the winners of that, and those winners are actually going through a prototyping phase now with our help to try to make these rapidly deployable ventilators. And now there's even discussions with countries like Nigeria about how could these types of ventilators be deployed in Nigeria. So those are the types of things that we're focused on now with the technology and network that we have.
So an interesting decision the company made early on was to publicly share your production processes for the shield production so other manufacturers could get in on it due to the emergency nature of what was happening. Why did the company make that decision, and how has it affected your business in one way or the other?
Yeah, and for us, again, it goes back to that second reaction I mentioned that we had, which was really how do we leverage our technology and our customers to help the greater good here. So for us, that was a no-brainer in terms of making that publicly available. Our goal was to get that out in the hands of as many as possible.
And do you have any sense for how many other manufacturers in total jumped on the train then?
Yeah, so we had quite a few. I mean, like I said, we had over 100 companies that were part of the coalition that we were, working together on. And the neat thing about once you make those type of files public, other people get to see them. They have ideas on how to improve the design. And the great thing about 3D printing, it's an entirely digital process. So we can quickly iterate on the design. We can actually print out a shield, test it on somebody, realize that we want to tweak this, tweak that, go back to the design, update it, print it again, test it, and so forth. So that's what that process allowed us to do, is to make sure that we continually improve the shield itself.
So theoretically, the other companies that took your template, if you will, and moved with it might be making something that's slightly different, or that they've optimized to their production processes, et cetera.
Yeah, absolutely.
Okay, interesting. So obviously, Stratasys continues in business doing other things during this pandemic. How have you managed your regular production schedule on top of producing PPE?
Yeah, well, the good thing is that we've got a pretty large capacity in terms of our ability to leverage our own printers and the customer printers and so forth. So we were able to make all of that PPE without much interruption at all to our regular production of systems and materials and so forth. In fact, as part of our Stratasys direct manufacturing services business, we have the largest 3D printing capacity in North America. And so we've got literally hundreds of systems of all sorts of different technologies in 3D printing that we can tap into and use. And we've got those sites from Minnesota to California to Texas. And so having all of that capacity on, at our fingertips allowed us to maintain regular production of our business as well.
Do you have any sense, I mean, given you're involved in this on sort of an emergency basis, we keep hearing of ongoing shortages locally, nationally, globally. I've read some things about supply chain with PPE that indicate it may be a couple of years and require actually government sort of guaranteeing companies sort of making the needed manufacturing changes to continue to produce the quantities available. Do you see this as being an ongoing thing for Stratasys, or do you see kind of moving out of this niche once there are sufficient traditional supply chains operating?
Yeah, I think it'll go into different places depending upon the particular need and the application. So like I said, face shields, a lot of that has moved now to traditional manufacturing, and that makes sense. But again, back to these ventilators, there's a lot of pressure on quick turn on the ventilators. And we work with General Motors, for example, out of Detroit, and they originally invested in Stratasys for factory floor tooling improvements, so jigs and fixtures and end of arm type tools and so forth. And then they were awarded a big government contract a few months ago that asked them to rapidly produce 30,000 ventilators by the end of August. And so GM had to essentially retool an automotive line to be producing ventilators. And they had to go to the original ventilator manufacturer and get the tooling data and essentially reverse engineer it in a way that we could then 3D print those tools. And so they ended up using all Stratasys equipment for 3D printed tools to reconfigure this line in short notice, from producing cars to producing ventilators. And the good news is that they're on track to meet their obligation, which is 30,000 of these ventilators from General Motors by the end of August here.
Has the success, or has the integration of 3D printing into this process sort of proved something to more traditionally minded companies that didn't necessarily see 3D printing applicability? Has you sort of created some new awareness of the technology among sort of old manufacturing?
Yeah, I think so. It's a great point. If you look several years ago, 3D printing was a lot in the mainstream news and so forth. A lot of that was more around consumer applications, which haven't necessarily materialized, but what is materializing is the industrial and healthcare applications of 3D printing. And those have continued to develop and expand. And I think that this moment here has allowed 3D printing to really shine bright and show itself as a real viable technology, a complement to traditional manufacturing, especially where you have supply chain disruptions or issues. 3D printing is a fantastic answer. And we've had a lot more attention from executives in larger companies over the last few months that have started to realize, even within their own companies, they have this 3D printing capability and talent, but they never realized it could be used for such applications and for rethinking how their supply chain is set up and so forth. And so coming out of the pandemic, we absolutely expect 3D printing to be top of mind more at the executive level in manufacturing companies as they start to think about those critical supply components and how do they make sure that they've got that nearby versus having to depend on a supply chain that spans overseas.
I mean, I think it's very significant. I mean, I think I was hearing the CEO of Clorox say the other day that they anticipated certain types of wipes being supply constrained for years to come still, that hand sanitizer they've caught up with, but there's something about the wipes. So, I mean, nimbleness of supply chain is something that clearly is an issue globally, if not in the US for sure. And so it's heartening to hear that you guys have maybe shown some ways to return some of that flexibility back to the supply chain. So beyond PPE, MedTech is a focus for you guys. Can you talk a little bit about what sort of other innovations Stratasys is working on? I've heard some things about skin replacement products and the like, but I'd let you speak about it.
Sure. So, that's a very exciting space to be able to apply the benefits of 3D printing to providing better patient outcomes. And one of the solutions that we've been working on over the last couple of years is something we call a digital anatomy solution. And essentially what we're trying to do is using software and material science and our printing technology is be able to essentially recreate the human body, where we'd be able to print lifelike type organs and so forth, so that feel like skin, bone, blood vessels, tissue, etc. And we've been making really good progress on this over the last couple of years. We've got a lot of key collaborators in the medical space that have been helping with this development. But really what's exciting about that is twofold. One, the ability to rethink how training is done for physicians, which today generally relies on cadavers or animal models or mannequins and so forth. And the ultimate vision there is if you can basically get a certain pathology that you want trained on, and to be able to print that and replicate that in Minnesota, in Boston, in Malaysia, wherever around the world, that has tremendous value in terms of kind of scaling expertise at a standardized level. The other big benefit of that is at the OEM level to really development and deployment of new medical devices, and to be able to shrink that time cycle, because now you can actually test those devices on things that are 3D printed versus having to wait for, let's say, a cadaver with the right conditions or animals or whatever the case is, which are generally much longer. So we're quite excited about that, and the last big benefit of that is down at the patient level, particularly in kids, where the anatomy is more complex, more unique, and to be able to replicate that and to be able to actually put something that the surgeon's going to go operate on in their hands 3 or 4 days ahead of the surgery, and let them actually do a walkthrough or a practice and consult other physicians, that is already showing some real viability in improving patient outcomes.
I assume, I mean, one of the issues with medical technology is, as you talked about, the really long testing and proving cycles. Is there any difference with a 3D printed item in terms of the human body's capacity to accept it or not reject it per se, as there are with transplanted body components from humans or animals?
Yeah, so there's different kind of classifications of how 3D printing is being used in medical. The examples I just mentioned are all out of the body.
Okay.
Stratasys is not involved in anything that's going inside your body.
I see, okay.
So we're more focused on kind of the replication of the body and leveraging that in order to improve training and then actual surgical planning and so forth.
Gotcha. Well, thank you. So we have an audience question lined up, but before we dive into it, let's take a moment to hear from one of our sponsors.
To the honorees and finalists, congratulations. ProStaff is honored to celebrate this achievement with you, and we're proud to support manufacturing in Minnesota. Thank you and your teams for all that you do. Once again, congratulations.
Okay, well, welcome back. We have an audience question. I think Rich is with us. Rich is. An audience member wanted to know, Rich, if you could talk a little bit about Stratasys's 3D fashion printing. So to talk about a totally different niche, although human body related.
Yeah, absolutely. So again, the value of 3D printing with regarding personalization applies to healthcare, also applies to fashion and accessories and so forth. So over the last few years, we've worked with some of the world's leading designers and have created some pretty exotic dresses and so forth that you'll see out on various runways. But I think what I'm more excited about is the potential in the future to actually be able to print on fabrics and different sorts of textiles. And we're at the early stage of that, but thanks to some of those same developments that we're making in our polyjet technology that we're using for medical, same concepts we're applying on printing on clothing. So we're at an early stage of that, but we think that that can represent a very unique business opportunity that is unmatchable today. You can't do it today in the way we're going about it. And a number of the major fashion manufacturers are actually quite excited about the potential of that, because you can start to really think about someone being able to personalize different sorts of apparel in a way of leveraging the traditional garment plus the 3D printed design architecture on top, and create some pretty unique combinations. So that's something I think we'll hear and see more about from Stratasys in the future.
Does it have the potential to bring the high cost of couture fashion down, or is that likely to remain unchanged?
That's probably likely to remain unchanged, at least for the short term.
Okay. Thank you, Rich, very much. All this was very fascinating, and we appreciate your time today. Thanks again for joining us. We want to thank our sponsors, PNC Bank, ProStaff, and Ware Technology Services, and our industry partners, Minnesota Precision Manufacturing Association and Manufacturers Alliance. Thank you to all of you for joining us. We hope you tune in again on Tuesday to hear from John Schwanke, President of Lakeview Industries. This webinar will be available online in the coming days. Have a great remainder of your day. Thanks again.
Thank you.